Hi there. I hope you can hear me. So if you can, just say hi in the chat or something similar. I know you're fine. Okay, great. So we'll start in a minute or two. Let's see that others join. What I'm going to do today, this is for testRTC. What we're going to do today is play a bit with monitoring. And differently than what we did in the past, I'm not going to actually write tests and run them because it's monitors. I've written the tests and started executing them, well, last month at around the time we did the previous webinar here. So what we're going to do is to explore the results and look at them. Okay? So let's start and see how things go. So my name is Tzachi Levent-Levi. I'm CEO and co-founder of testRTC. And we're going to talk about how to deal with WebRTC monitoring, the different approaches and what it means for us. So the first question to ask is, what's monitoring anyway? Okay, if you think about it, we've got an application or a service, it is running, we just need to know if it's still there and operating properly. And the way you do it today is by using different types of tools like Nagios or BMC, which we go and install, open source or commercial. These tools can collect metrics, they look at anomalies, and then we rinse and repeat. We collect more metrics, we search for more anomalies, and we do that over time, over and over again. Now, we've got tools like Nagios and BMC. These are on-premise, focused on metrics, machine metrics. Then we've got things like Neuralink and Datadog, which run in the cloud for similar types of services. It's called APM, Application Monitoring. And then there's things like Elasticsearch or Splunk that collect logs and can search the logs for certain patterns. That means, again, being able to look at metrics and look for anomalies within these metrics. Okay, now we can do this for WebRTC applications as well. The only problem is that there is one thing that we won't be actually looking at in that kind of a thing. And that's the actual, let's call it, is a system is up and running and if it running well. Now, why is that? Because when we collect set metrics with these types of services, the things that we usually collect is things like CPU, storage, network performance, things that the system or the machine gives us. But we don't really know if there is any packet loss on the network, if the video quality is fine, or even if the service is working properly. Okay, you can get to a point where all the machines look pretty fine, so everything's okay. But when you try to connect a call, it doesn't connect because something in the database doesn't connect and you can't log in, or you do a call and the data center itself is not connected properly towards the users that are trying to reach it out. Okay, so when you go and monitor WebRTC, what you're trying to do is not simply monitoring the machines, but monitor the end-to-end service, understanding what exactly is happening. So here's what we're going to do today. We're going to watch and play with testRTC and look at a few demos that I've picked. We're going to look at results. For the last month, I've been running 3 different monitors from 3 different vendors. And these are the results that I got. I took a screenshot of our dashboard a couple of days ago for the post announcing this webinar. And what I did was this. I picked these 3 fair services almost in random, just things that are easy to find and use. For each, I created a simple script. So the script will go into the service, use 2 probes, 2 users on 2 browsers from the exact same location for each and every one of them. It will wait inside the service for 2 full minutes to collect media, and then it will leave. And I've executed them as a monitor. I've configured them to run as a monitor for a full month, every 15 minutes or so. Now, what I did, another thing that I did at the end of it was collect the results and put them in Google Sheets. Why Google Sheets? Well, because I could. That was the main reason. So the services that I picked was upRTC, Appearing, and Jitsi Meet. UpRTC, it's obvious. For me, it's the baseline of everything that is WebRTC. It comes from Google. It does a peer-to-peer call. There is no media server in the middle. It just, that's the only thing that it does. It was also a good example because this isn't a production service. There are people that are trying to use it as such, but I wanted to show the various challenges that are there with it. The second one that I picked was Appearing. It's stable, it's solid, everybody uses that. It runs on a mesh network. So again, peer-to-peer solution, then it's very easy to go and connect through that service. The third one was Jitsi Meet. The reason I took Jitsi Meet, beside the fact that it's free, is that it's different than the other two. It runs it as an SFU, and I force the media to go through the media server, and it runs with simulcast. It makes no sense for two users to do that, but I just force the system to work in a very certain way, just to show, to explain something and to show what happens with that using testRTC. So I've created scripts for all of them, connecting them or running them, invoking calls in them through testRTC. Then I took the results and just pushed them into Zapier using webhooks, and we'll see how that is done. Once inside Zapier, I collected success or failure results to understand what's happening, media scoring, okay, the quality of the call itself, and then I added a test rank link reference. So if there's a failure or a successful execution that I want to look at, I can just click and go to that. Once in Zapier, I pushed it out to Google Sheets, and the reason to go to Google Sheets is to be able to answer questions like, is this service stable? Does it offer any predictable quality results for its media? What kind of failures does it exhibit? Okay, and we'll go through, some of the things in there, and I've created additional sheets and a few graphs in there just for the fun of it. So let's move on. Well, let's go to the demo. If you have questions, just use the chat and decide. I'm assuming this will be a bit quiet today. Let me share my screen real quick. Okay. And let's pick this one. What entire screen? I didn't want the entire screen. Okay. Can you see my screen, by the way? It should be the testRTC dashboard. So this is a testRTC dashboard. Into my account, the 3 monitors are running. Ignore these, ribbon bands. They are bad in terms of what they show. We had a bit of an upgrade in a few days ago, and since then the ribbons have gone bonkers. So the first thing that I want to do is to show you a bit the monitors that I did, how they are configured. So let's go to the monitoring system. Pick up, let's say, the upRTC monitor. So each monitor here now runs every hour. We switched it to once an hour from once every 15 minutes. It was on 15 minutes for the last month. You'll see the results that were collected. And I didn't put any alarm on it. I didn't want to get emails when things failed because I just wanted to collect the data into Google Sheet. Now, this runs the test upRTC monitor, which is this test. There are similar tests, by the way, for both Jitsi and Appearing. They look the same, they operate the same, and they don't load at all, which is not nice. Let's see if I can reach the tests from here. Where's my monitor? Okay, let's see if I can Jitsi. Okay, it's here. Yes, okay. So this is a monitor. It has 2 probes in it. We will go into the run options in a second. It goes to upRTC. And the script is rather simple. I've got 2 users. The first one goes, it goes, opens the page, click the join button, takes the URL, set it in the session value to send it to the other user because it's ad hoc. The other user just joins, okay, and goes into the URL, and that's it. And then they both wait for 2 minutes. Let's pick the Jitsi one because I think it's easier to understand. The Jitsi monitor, this one. This one is the other monitor that is running. Okay, and in this case, what it does is the following. Both of them just go to the URL of the room, and the room URL is meet Jitsi /testRTC and the session index. The name we give the room, and that's it. We open the page, wait for it to load, 2 minutes of data, and we're done. In all cases, I've used two browsers, one running from the East US and the other from West US, with two different media sources. Let's go, for example, to the run history. So this shows all of the success and failures of the monitors. You can see that there's a failure for upRTC happening just now. Okay, an hour ago and just a few minutes ago. If I look at the Jitsi monitor, the last execution of it, I can go and check the quality, incoming, outgoing video bit rates. And then let's go towards one of the probes and just look at the media itself. Okay, so we've got media going Jitsi. This is remote view, this is local view, two different video sources, one 720p, the other 1080p. Why? Because I can. So that's what I did with all of them. Okay, nothing serious, nothing really interesting, but it collects all of the data, and I can look at results of the test that I've executed a month ago and still have it here to be able to debug it. So I've got the test. What we haven't looked at was this part here. This is the Jitsi monitor. Second, there is this webhook line over here. Webhook is a run option that allows us to send the result when a test finishes towards a specific service. We have customers using it to connect it to Splunk, Elasticsearch, BMC, Slack, okay, different type of services. What I wanted to do this time was connect the webhook towards Zapier, just because I wanted, to have the lines listed in a table. So I used Zapier. This is my Zapier account. I created a catch hook event. Okay, that's the webhook one. When you create a hook in Zapier as an entry point, what you get is this, this kind of a URL. And this is the exact URL, xdc1kh. I have it here, xdc1kh. You let it run about once or twice. You test, you get samples. This was a sample that was pulled when I played with it, and I got this information. This is a webhook that we send, the data that it has. So the status for this one was completed. There was a test run ID, what we don't care about. This is the URL of the test result. Okay, we've got the name of the monitor, the name of the specific run, and then the rank. Let's just open this one quickly. Okay, so this is a test run that was conducted a month ago when I started creating this webhook and this monitor and playing with it. This one was executed in January 25, 2019. And from here, I collected all the data. The rank is this one. This is the scoring for the media, if you recall that. testRTC goes look at the media channels and decide what's the number for the actual scoring. It relates to bitrate, packet loss, type of codecs that are used, resolutions, frame rate, and how much jitteriness there is in whatever is going on. How stable the service looks like. And then it picks a number. I don't care what the number is. What I care is the number going up or down as time goes by. So that's Zapier. Once I created the trigger, I went and created an action. I went to Google Sheets into my account and just placed in a spreadsheet, a specific spreadsheet in sheet number 1, this row. Okay, and the row includes the name of the monitor. I decided to collect everything to the same place, so I don't need to create multiple zaps in Zapier. Then the time, the current time when the data got pushed, the status of the test, the rank, the reason, if there is a failure, and the URL. Okay? Now I have this one, and then the 3 monitors that are running. Since then, I stopped the ZAP. Okay, so this ZAP is now inactive. I ran it for about a month, and the data was collected into this nice Google Sheet. You can see that I've got upRTC, GTC appearing, upRTC. And the timing when I started it is on the 25th near midnight my time. Okay, and then every 15 minutes, you see that it's running all 3 tests. And this has been conducting around 10,000 monitor runs with empty period and a month and a bit, okay, until the 3rd of March. Now the status here is completed most of the time. At some point, there is a failure here and there. Here's a failure of appearing, and there are failures. So the first thing that I wanted to do is to check what's happening. So I just created a pivot table. Okay. I can see these things also in testRTC, by the way. We'll see there in a moment as well. But I've created a pivot table. In the pivot table, I have this these 3 services, appearing, upRTC, and GTC. Each of them completed, roughly 3,200 tests. Those that haven't was because I started there a bit later or stopped earlier, things like that. And you can see the number of failures. So upRTC is almost, 100 failures for 30,000. It's a lot. Okay, let's see. Can I do this? Yes. I don't like, almost 6% of failure rate. And then GTC has about 1% failure rate, and we'll check what that means. And appearing has the least. Okay, again, that's tests that we've conducted. A bit of these might be issues with our infrastructure. Almost none of them are at this point in time with us. Okay, so that's what we did. This is the pivot table, and you see that upRTC is failing a lot more. Now, if you recall the screenshot that I've given you of the actual tests, there were a lot more failures with upRTC than the rest, and they came in batches. What do I mean by batches? Let's go and see this. The first thing I did then was take this sheet and normalize the scoring. I had to normalize the scoring due to 2 things. First of all, if it's filtered, yes. If I filter it for failure, then what you'll now see is that in failures, I get these weird numbers of negative values or thousands or numbers that are just too high or too low. I didn't want them to do bad things for me, so I just switched all of them into zeros. That was the first thing. The second thing was a bug that we found this month, and we fixed it in the next release, so we're going to not find it anymore. Sorry. Is that sometimes, even with, let's remove it. Select all. Sometimes what happens is that we get high scoring values when they shouldn't be that. Okay, that's because of a bug in our RTCP that reports wrong numbers, and we decide wrong calculations out of that. And it happens only for the GT monitor for some reason, but we fixed that. So what I did was normalize it. I've created a new table, which is almost the same, but here I had added a rule. If the test is completed, then if the number is below 0, we normalize it to 0. If the number is above 10, we normalize it to 10, and otherwise the number is 0. So all failures, like this one, immediately move towards 0, shift to 0, and everything that is above a 10 will shift to a 10. Now, it was hard to work with this one, so I split it into 2 different sheets, and let's look at the upRTC sheet for an example. So I took all of the upRTC tests, test run, and placed them here, and then I created a kind of a table between date and score. So I'm looking at this row and this row, these 2 rows. Okay, what you see is almost all tests are here at 2.9.2 or something like that in their values. There are a few outliers because this is networking, okay, but that's stable. It makes sense also because remember that what we are doing is running this peer-to-peer. So it goes through no infrastructure or backend other than what our probes use. And they use a pretty good network. And then you see these zeros. And these are all of the failure points within the service, within upRTC. There are quite a lot of them. Okay? If I scroll down, you see, every once in a while there is a failure. We'll watch a failure or two just to see what happens. And then you've got these batches of failures, one after the other. And that happens rather a lot with testRTC, with upRTC. Okay? So here is a downtime of about 2 hours of upRTC. It just didn't work. Here, another downtime of 2.5 hours. Scrolling down. I'll answer in a moment. Okay, so a lot of things that can be found here. So let's see, if one wanted to monitor whether a service has acceptable video quality when relaying via turn TLS, would one create a test using HTTPS only network and set an exception in the script that video bitrate? Yes and no. Okay, and I'll get into that in a moment, David. So that's what we did here, and these are the results. Let's look at testRTC just to see what it means. So I'm going to go to monitor history, and I'm going to look only at failures and only at upRTC. It's this one. Okay, so these were the monitors that happened through this time, most of them from March. Okay, you can see March 10, a bunch of them. All of them failed test expectation, audio in 0, and then you've got this one. Let's see it. Look at these two different failure. We'll pick one at random and go to the first probe. So here what happens is that there is no data for WebRTC. It just collected nothing at all. There was no media. And if I look at the screenshots, the second screenshot is actually a screenshot within the call, and you see here the message that comes specifically from upRTC. WebSocket open error, blah, 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 blah. There is a socket issues with upRTC. I can go and look at the browser logs. This is a console logs that were spewed into the browser, and that's what it said. WebSocket connection to upRTC ws websocket.org/ws. WebSocket opening handshake timed out. So upRTC has an issue with that, and it had that issue for about 2-3 hours in this round. Okay, let's go back a bit. So this is this one. It's the same failure, WebSocket issue every once in a while with upRTC. These are slightly different. Let's go check one of them. So here the second one waited and never got into the room. If we look at the first one, then the media is actually fine. Everything's fine. It's joined the room and it's waiting. It is sending no media out, but the peer connection got connected. Otherwise, we wouldn't have these channels or these empty graphs. So we tried to connect and couldn't. Something didn't let it. There is nothing here that will tell you why. I know because I searched already. Okay. Everything seems rather okay-ish. So this is something that you need to go and start debugging a bit more. Okay. If I go to the second probe, the one that was waiting, let's see what happens with him. No media at all. It just stuck in a failure. So you see these things and you can try to debug them and find the issues. If I were, Google looking at it through testRTC, I would go and put the Har File collection and then look at the Har File at what happens on the WebSocket side or HTTP side of their service. Now, let's look at what happens with Jitsi. The Jitsi monitor is a bit different. It fails a lot less. As you can see, it failed a bit on the 17th, the 6th, on February 1st. There was a lot of failures. Okay. And then there are a few times in February 1st, January, but not a lot of them. If we go and pick one of them at random again, so there is a text expectation failure. Let's go check. This is a probe in question. It loaded there. There is everything and nothing at the same time. So we send media and we receive nothing on the network. So that's what we have. It's only us and something's totally wrong and weird here. Should probably be checked somehow. We can go and look at the browser logs again. I'm not an expert at the console logs of Jitsi. Doesn't seem to have error in set user priorities. Not sure that it means anything. We've got issues here, with libraries, uncaught, DOM exception. Again, not sure if it matters. Happens again and again. This one, DOM exception. Then you've got this one, connectivity. Okay, so again, you can go look at the logs and start to figure out why this is happening. Let's look at the other probe, if it has something interesting in it. The other one, it's also in a call. So they are both in the same call within the same room, but they can't see each other. They just send and don't receive anything. So that's interesting. If I look at what happens here for Jitsi, okay, so same thing, but all over the place. Remember, the zeros are failures, the tens are issues with our logging mechanisms, and the rest are either here or here. Now, Jitsi is all over the place because it's an SFU. With SFU, the data goes into the server. And what I'm doing on top of that, let's see a result of sorts. Okay, what I'm doing on top of that is running it as an SFU. And when I run things as an SFU, I assume this is an SFU, by the way. Let's check that. I just don't remember how I did it. Okay, so we have this connectivity in the beginning, and then we've got these lines over there. Okay, and you see that the outgoing is kind of jittery until it gets into the 2.5 megabit per second. So these are the kind of issues that you can watch and understand what they're doing. With Jitsi, let's look quickly at the test itself. In the test, no, I'm doing it, I guess, probably it does peer-to-peer, but it doesn't look like that. Okay, something is probably wrong with Jitsi and how it is configured at the moment. Or I don't understand how it is running for this specific use case. With appearing, and then I'll answer your questions, David. With appearing, what we have is this. Everything is at either this line here, which is the 8.7, or the line below, the 7.9, I think, something like that, 7.8. So something weird is happening because we've got two very distinct ranks of video happening for the exact same scenario. It would be interesting to go open two of these and understand why the differences. And there we have a bit of failures. So let's find the failures. I'll go again to the monitoring run history. I'll pick failures and the appearing monitor. So here the failures are all the same. They're, spread in between. They don't happen at the same time all the time. Let's go to the first one. The first one has this. So he got into the room and he's waiting for someone to join him. Okay. And then let's go to the next user. And the next user just got to failure. Why is that? Video stream container wasn't there. Let's see what it means. I'll open the test. This is a test for appearing, same webhook. We go to appearing. And what we do is go to the room appearing, testRTC. That's it. It's a static room. Both clients doing the same thing. So they open the URL, wait for the body element, and wait for video stream container. And for some stupid reason, this doesn't happen for this specific browser. Okay, so the page didn't load well. Not sure why. Again, it needs to be debugged. But that's like the type of a problem that you will find with appearing in our monitor. And it's sporadic, it doesn't happen that much. So what have we done so far? We've created 3 monitors, very simple ones. We've executed them every 15 minutes or so because it made sense. And then we collected the data through Zapier into Google Sheet and looked at the data there. I could have done, could have gone and sent that data into Splunk and did searches there, or Elasticsearch. I could have taken the data and put it in Agios in order to create a dashboard, okay, that is outside of testRTC, because there are other things that I'm as a company is going to monitor. I'm not only monitoring WebRTC. Okay. We've seen how ranking is used, the scoring for the media. We've seen how webhooks are used. And essentially, we've played a bit with the service. Let me open back the presentation real quick, and then I'll answer your questions, David. So if I wanted to, I should have left it open. Okay, back to screen sharing. Sorry for that. That was stupid of me. So the first question was, if I want to actually test my turn servers, what can I do? So let's do it now. Okay, this is my screen again. Let's say that I want to do it for Jitsi. Jitsi monitor, this one. Okay, so the only thing I need to do now is to take the firewall here and yes, just do HTTPS allowed on both of them. Sorry, not this one, this one. Firewall, HTTPS allowed. That's it. Now, the next time this monitor will run, testRTC will block UDP and block all ports except for 443. And then it will try to run Jitsi. If it succeeds, then it means that it went through it went through the turn TLS servers that Jitsi is configured to work with. Okay? So that will cause what you're trying to achieve. Now, what do you need to do with the expectations? Probably nothing, because if it doesn't connect, it doesn't connect. We automatically fail if there is no media anyway. You can check for expectations like bit rates and things like that. Okay, the most banal expectation that I have here for the Jitsi tests is that I want the audio incoming streams to be above 1, audio and video, and the outgoing to be below 2. Okay, and I also want to have bitrate onto all of the channels. And again, I can say I want the video bitrate to be above 400. Why? Just because. And I can check for packet loss and other things as well. So it's up to me to decide how I configure that. Now, what I meant was Har File, not hard file. And I think that I actually have that configured for upRTC, or I might not. Let's find the upRTC monitor real quick. This one. And no, not here. So there is no Har File. But again, if I do this, then what happens is I will start collecting Har files. What can I do with the Har file? Let's open the documentation. Yes, that's what I'm trying to answer. So a Har file is a browser file today. It's not here. Here. A Har file is a file that a browser creates automatically when you run over the network. Okay? It collects all of the HTTP traffic of the browser into a kind of a JSON file that we collect, and then if we collect it, you can go and visualize it with an external viewer. And the viewer will give you the exact things of what got loaded by the browser and when, all of the HTTP traffic, requests and responses. We've added that because we actually had a customer that needed it. I think that we've got it on our blog. Let's see. Real quick, I want to show you a kind of this one. Dun, 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 dun. This is the content of a Har file. Okay, what you see here, for example, is HTTP stream connecting the SSLs and URL request, and then the whole shebang of how it looks like. Har file doesn't come instead of getstats because Har file includes everything but WebRTC traffic. Okay, you will find here SDP negotiation, but you won't find here the media itself. So it's a mixture of both. We added that because we had a customer that had a 502, internal server coming up in his monitor every once in a while, and he couldn't find why, because he's got a distributed system and he wanted to go and find which server caused that, and he just couldn't. So Sander, how to find if a WebRTC session is running low on cellular bandwidth and adaptive bitrate switched to a lower resolution? So that you should probably go to the previous one that we did, the previous session that we did last month. If you go to our blog, okay, so inside the blog, go to the how to test network behavior in testRTC. This will explain exactly how we do that. So you can either do it statically for the whole test by configuring a specific network, okay, or you can do it dynamically by using RTC, set network profile, and within a certain period of time, change the network conditions and see adaptively what happens to the network. Okay. Now, in order to see resolutions, we don't show it immediately. If I go to this test and look at the results, today we don't have resolutions in these graphs, but if I open the advanced WebRTC analytics, PropRTC, it is boring, but it's there. Then I can go and search for height, yes. So the height, and let's remove bits per second, frames encoded, packets encode per second, frame width. Okay, so these would be the height and width. So you can see that the frames that we've got here is 1080p, and that started here. Before that, it was 720p or something close to that. Okay, and this is how the resolution grew up in this specific test. Okay, so you can go to the previous session and watch the recording there. We can do all of these things today. Any other questions? Okay. So let's find the presentation again in order to be able to say goodbye nicely. So we've seen a demo of testRTC used for monitoring purposes. I played with 3 different services for the fun of it. I picked up upRTC because I knew that it is failing, and I wanted to see how it fails and how many failures you have within a month. We've seen that it's about 5% of the month it's down for some reason. But we also saw that other services have failures here and there that can be resolved. Now, if you're interested and you're here in the webinar, you can just contact us and we'll give you 1 month free trial for a monitoring service. We will set it up with you, create a script together so you can understand how things work and then decide if you want to continue with us with a commercial subscription or not. Okay. And yes, David, there will be a recording inside the blog. It will probably be there next week when I'll find the time to actually write it. So thank you all for being here with me today. I hope you enjoyed it, and see you next time.